Hello. Not sure. All right, so looking at the problems, 14 and 15, it looks like they're really easy because all we do is we use the equations like above. 25, yeah, it's just a matter of writing out the equations and then rearranging to solve for the h. And we have 19 there. 19 is... Yeah, 19 is just going to be using the properties of a triangle, so adds up to 180 degrees. Use the definition of bisect. So it looks like ABF is 32.5, BC is 122.5, E is 25. Did anybody know how to do number 25?
No, I think is this lesson about similar? I didn't use similar lessons.
Okay, so for this one, you don't actually need similar triangles. Oh, it might be possible that way, but this one is you kind of have to think. Okay, yeah. So this one you kind of have to think outside the box a little bit. All right. So Warren, you got it right. So Rachel and Kimberly, did you guys skip? Okay. So how did you guys do it?
So you just click on the dividends.
Yeah.
And then I can write it on the dividends like angle BBC and angle IPB are congruent with the vertical angles.
Okay.
And then I use ASC, that choose triangle.
Used ASA. AAS.
It can tell you that those that BC and FP are congruent. Like you can find.
Is this something in lesson 8? Oh, okay. Okay, so that was something you guys learned from Jimmy last week? Okay. Oh, sure. And then after that. Okay. Okay. So what? So you used angle side, or you have so you have angle C. You have okay, yeah, reflexive property, and then AFB, AFD. Why is this one congruent to this side again? Okay, so you guys remember the thing we did with triangles 2 classes ago, right? Like, do you guys remember why can we prove that the sum of the angles of a triangle add to 180? Yeah, you draw a parallel line. So let's try think if we can somehow use that in this one. Like, let's say we know C is going to be congruent to E, and we know BC is going to be congruent to FE. So we have a side and we have an angle. Now let's just say that we take any combination of the two, and then how is there any way we can prove like BCF, or I guess the one you guys were trying to do, ACF, is congruent to the other side?
They're already given.
You are given a side and an angle. I'm talking about the whole triangle. Show the congruence for either this guy or the bigger one. Okay. Okay. What angle did you just say? And which one's the congruent angle? Okay. Yeah, sure. Okay. What if so you know these two triangles are congruent now, right?
Yeah.
So what if you could take this angle right over here and this angle right over here, and do you know if angle FBD and DBF are congruent? Okay, yeah. So then, you know, this is congruent, you know, this is congruent. So what does that say about this side and this side, the angles? They're supplementary and they're also congruent. So there you go. It forces the angles to be congruent, and therefore the sides must be the same because the angles are the same.
I found like
Oh, you did it by isosceles trapezoid? I suppose it's also possible that way. You would have to prove if... Oh yeah, you would have to somehow show that they're parallel, which could be done by if you could find like the if like this angle is congruent to this one, then you have a set of the alternate interior angles. So if you can show that, then you have a isosceles trapezoid. The same length? Are you referring to the sides or the... Yeah, the sides are the same, and then the top line. And so remember what we learned about parallel lines? It's like if you can show like the corresponding angles, the alternate interior angles, alternate exterior angles, if these are somehow congruent, then you know that they are parallel for sure. So yeah, I guess it's also possible that way. It might take a little bit more work, but yeah. All right, let's move on to chapter 8. So I heard from Jimmy you guys covered up to 8.2, right? And you guys all went through ratio and proportion and similarity. Now this one is pretty useful. This one is really important in geometry. It's like another way to show that triangles are congruent apart from proving that their sides and angles are the same. Did Jimmy get through the whole 8.2? Okay, so you guys know all these theorems. The ratio of the perimeter of any two similar polygons equals the ratio of any pair of corresponding sides. So that means it's you can just, like, if you have MO, you know that it's going to be similar to KH. If you divide this side by this side, then you should get the same ratio as dividing this side by this side. And then let's say you want to find the side of KJ, you know the ratio of MO over KH. So all you have to do is multiply that ratio to the side length. Or, yeah, the side length of this guy to get this guy. Okay. So if there's anything that wasn't covered, because this is all based on the one before. So if there's anything you guys don't understand, like, feel free to ask immediately. So methods of proving triangles similar. This is how we're actually going to use similar triangles. You guys did this? So you guys know the AAA postulate? Theorem. SAS. Oh, okay. So this one? You guys finished 8.3? All right. Let me just pick a random problem. See if you guys know how to do it. Oh yeah. Okay. Let's see. Okay, let's look at 19.8. Is triangle PQT similar to PRS? Why or why not? So what's the ratio of the sides?
It's not 3.
The ratio is 2 to 5? Try writing it out. I think you guys are kind of confusing yourselves. But yeah, just write out the ratio of small triangle, write out the ratio of large triangle. Hmm, 2 to 5. Okay. So yeah, 19.8. They are similar. How are you guys using ratio though? Like, how are you guys getting 2 to 5? So the small one is 4 over 6. The bigger one is 10 over 15, correct? I'm comparing the ratio of the sides. Like how I'm trying to figure out like where. Yeah, 6 is QR. Uh-huh. plus QR? PT plus QR?
PQ plus PQ.
Oh, when you guys are proving triangles are similar, so that means that whatever for this side, then you multiply by a fixed amount, and then you get the whole side length, right? So, so it seems like from my understanding that if you multiply this side by 1.5, you should get the length of the PR. And if you multiply the 6 by 1.5, you should get the length of the whole thing. Or, no, wait. Hold up. Oh, wait, no, it is, it's not 1.5, it's 2.5. Yeah, 5/2. So, yeah, I guess you could say that the ratio is 2/5 if you go from the large one down. So it is kind of the same thing. Okay, is QT parallel to RS?
Yes.
And why?
We have this, like, it's already like, we already have the same angle
Mhm.
in there, and the two sides are similar.
Mhm.
It is only like one side that's possible.
Think about how we can prove parallel lines. Yeah, so which angles can we say are similar?
QTP and RS.
QTP and RST. Yeah, so since you know that these are congruent, then these are also corresponding angles, and corresponding angles being congruent, you know that that makes that these two lines have to be parallel. Okay, so hopefully you guys have covered. Let's just go through this really fast. If two triangles are similar, are they congruent? Yeah, sometimes, because you can have triangles of the same. What does similar refer to? Similar refers to. Yeah, so that doesn't always necessarily mean they have to be the same. B, if two triangles are congruent, then they are similar. So I hear, okay, yeah, always, because that's kind of the definition of congruent and similar. See, an obtuse triangle is similar to an acute triangle. Yeah, never, because you can never have a obtuse angle in a acute. Two right triangles are similar. Yeah, two equilateral polygons are similar.
Sometimes it is the same kind of polygon.
So what does it mean for something to be equilateral? Assume this is referring to the same polygon. Like say they're both like hexagons or whatever, or both octagons. Yeah, in that case, it would it should always be similar. So that should be the same case as with two equilateral triangles. Two rectangles are similar if neither is a square. Yeah, sometimes. Okay, cool. So it looks like you guys have 8.3 down. So we can go on to 8.4. Oh, hey. All right. So apparently a lot of what we've been just doing, Jimmy went over. So you haven't missed very much, I think. Okay. So 8.4 is congruences and proportions in similar triangles. If we know that two triangles are congruent, we can use the definition of congruent triangles, CPCDC, to prove that pairs of angles and sides are congruent. In like fashion, once we know that two triangles are similar, we can use the definition of similar polygons to prove that corresponding sides of the triangles are proportional and corresponding angles are congruent. So if a problem asks you to prove that the products of the measures of the sides are equal, try using the means extreme product theorem. So what is the mean extreme product theorem? Yeah, cross multiply. Just use the ratios. So given you have triangles are similar, prove that A is congruent to D. Well, you know that corresponding angles of similar triangles are congruent. So this looks like a very small s. Yeah. So. Oh, okay. So I think what that just refers to is just triangle S with a S. So the squiggly means similar. And then, yeah. What? Yeah, so imagine just triangles. I don't know. They could just use like, yeah, apostrophe S, but we have that. So, okay. Given you have the same triangles, prove AB over DE is equal to AC over DF. So corresponding sides of similar triangles are proportional. Means extreme product theorem, you just take the ratio and then you just multiply over. Now this leads us to be able to do some things that you wouldn't be able to like realize just by looking at like this. So let's just say you want to prove AB times C equals AC times BD. Well, just by looking at the diagram, it's like it's kind of hard to see like how can I prove that this multiplied by this is equal to this multiplied by this. Like it's just like wow. Yeah, because you can say because of the parallel lines that the angles are congruent. So ABD is congruent with C. You know, the other side is congruent with E, and then you have use your AA theorem to show that the two triangles are congruent. And can somebody tell me really fast what is it? What's the AA theorem say? Okay, so can anybody see like how does using AA allow us to prove that the two triangles are congruent? And no choice theorem says. So that doesn't that prove triangles are similar, right? Like how do we get from that definition of similarity to this this line of congruent? Yeah, proving that the triangles are congruent.
What is the AA theorem?
Okay, I will pull it back up. Wait, Anish, were you here when Jimmy was lecturing?
Yeah.
Okay, that's yeah, I don't know if it works on a PDF, but it should be somewhere here. Okay, here we go. So does Anish, does this help you remember anything? But if there exists a corresponding between the vertices of two triangles such that two angles.
Oh, okay.
Yeah.
Yeah, I got this.
Okay. So yeah, just by looking at this example, so we know that using AA states that two triangles are going to be similar, but in this case, our statement says that two triangles are going to be congruent as a result of this. So can anybody like see like where does this congruence come in from? This is actually kind of like ABD is congruent to ACE. I think this might be a typo actually, because like how can this be congruent to this?
It could be like similar.
But this diagram is so misleading then, because then why isn't this the same line as this? So I actually honestly think that this might be a typo, but let's scroll up and down to see if yeah, I think it's a typo because here they use the similarity with AA. Okay, so yeah, never make this mistake, by the way. Like don't confuse congruence with similarity, because even though like they're very their properties are like very similar, right? Because you're both using angles or you're using sides to show either similarity or congruence, but always make sure never to mix these up, because it could send you a long ways off if you do. And with these kinds of problems, you have a lot of flagpole and shadow problems. So let's say you're outside and you want to get sun, and you notice a 20-meter flagpole casts a 25-meter shadow. Nearby is a telephone that casts a shadow. So then by using this, you can tell how tall is the telephone pole by drawing out the pictures. Like drawing this out is always very helpful. 28. Let's see what. Yeah, so they get 28 because by using the ratios, you get that.
But where did it say that they were similar to each other?
Okay, so that's a good question. So whenever you have shadow or any kind of like yeah, just whenever you have any kind of shadow problem, you can assume that this is happening at the same time. So the angle that the light hits the pole or the angle that the light hits the whatever else, it's always going to be the same at that same instance of time. So just assume that they're similar.
Why do you talk about like this? The sun is very far away from us.
So I think so. The sun is very far away from us. Its rays are nearly parallel. So I guess what if the rays of the light were not parallel? Then it kind of is, because let's say you're coming in from a lot of different angles, and then like the light, let's say it wasn't just one nice line of light. Let's say like your light is coming in from this way, so then it'll hit the ground at this point. Light's coming in from this way, it'll hit it here. So for convenience, we just assume that the rays of light are parallel and they always hit at the same angle.
Why do you see that in the solution?
The what?
Why do you put it in the solution?
It's probably something that they could have also put up there, but I think, yeah, it's just, it's kind of like you just assume that it's the same. All right, so you have this figure here. You want to prove Sx times Yw is going to be equal to Sv times Wt. So whenever you see this and you see a figure, then the first thing you should think of is that theorem that you guys just told me, the means extreme or means extreme product theorem. So always try to when you're trying to prove this, always just try to think of how can I rearrange this so I get it in a form like this. And then once you get that form, then you know that all you have to do is find or prove that the triangles are similar. So that's so working backwards is sometimes a very valuable tool to use. So you have the initial thing that you're trying to prove, and you go up. You have the ratio. You know that you're gonna have to prove the similar triangles, and yeah, you guys know how to get here because all you have to do is get AA. So if we start from the top, we just use all the givens. We go about saying whatever statements were given from the statements. So we know that this is right angle, this is right angle. They must be congruent, and the triangles are similar because of AA. And there you go. The rest is, you guys know how to do it. So let's try that with 12. Given you have this parallelogram. Yeah.
What is the means of streams?
Okay. So did you write this stuff down when Jimmy was going over it?
Yeah, I did.
Okay. It should be in your notes. It should also be somewhere here. Okay. If a product of a pair of non-zero numbers is equal to the product of another pair of non-zero numbers, then
Oh, okay.
Yeah.
Yeah, I don't write the names over here. So
okay, always write down names because they're very useful to know how to call them. All right. So let's try to do number 12. Anybody figured it out? All right, so can somebody just tell me like what's going to be our approach to solving this problem? We want to prove this, and how should we go about trying to prove this? Like what's going to be the plan here? You got it? Oh, that's fine. Anybody can just.
Yeah.
Okay, yeah. So you have your givens, and then next.
Can you say that like GF is congruent to EF?
Yes.
And then like you can prove that age like you can prove that AB is congruent to EF, so then AB will be congruent to GF because
But
the,
you don't know where So you know F is going to be a midpoint, right? But do you know if B is going to be a midpoint?
no, but see they already gave you that oh that's angle. Okay.
So here's a hint. What if you don't even need that first F is the midpoint?
Because it's a parallelogram,
Mm-hmm.
B and A are
Mm-hmm.
literally how you stick the angles by neutral zero.
Yeah. Yeah. So they're similar, and then after you get that they're similar, then you can just use the ratios of the similar triangles have to be equal, because that's the definition of similar triangles. So yeah, we didn't even need this F is the midpoint of EG statement because we know this is a parallelogram. So by definition of parallelogram, like on that printout I gave you, like that's kind of why I printed it out too, because it shows up so many times. But we know that this angle have to be congruent with this one. This angle has to be congruent with this one. So A is congruent to E, and we are given ABH is congruent to EFT. So that's two angles down. Now, no choice theorem says that third one must be congruent with the third one. So there we go. There's the three angles that show that the two triangles are similar. So since we know that the two triangles are similar, take two sides, divide them, you get a ratio. Rearrange that ratio, and then you can easily say that AB times FD is equal to HB times GF. All right, let's try this 20, this shadow problem. Anish, you finished?
Yeah.
All right. So let's say what's one equation or what's like one ratio I can use?
3/12.
Why 3/12?
Because the shadow of the lamppost is 3. Yeah.
So think about what you're comparing. What is going to be the corresponding side to what?
Or you can use like x over 5.5, 5 because
All right. So let's say we go with that. Let's say we go with x over 5.5. We need to make this into an equation. So I'll put an equal sign. What's this going to be equal to? What's on the right hand side?
Or 3 plus x over 12.
Yeah. So we have 3 plus x over 12. Because you are comparing the bottom to the bottom, and you're comparing the top to the top. So that means that you're going to have now with this, it's just a matter of solving for x. So we have 12. We have 5.5. So 5.5 is also going to be equal to 11/2. So I'll just write it out as 11/2 plus 3. Let's multiply by both sides by 2. So you get 24 equals 11 x plus 3. And you get 24 over 11 minus 3 equals x. So this is what your x should be. And actually, no, wait, that's off because we get a negative answer, which can't be right. So something went wrong here. So something is off about what I have on the board because our answer is not positive.
I mean, if you make it like x minus 3/12.
But think about what is x going to be?
How long the shadow is.
So by subtracting 3, what does that mean in this context? This is a very good opportunity to find the error, find what I have done wrong, or alternatively, find an answer that gives you a positive value. So another
It should be 12x, not
12 x.
Is it possible?
Are you saying I should put
Oh
a?
yeah,
It should be
yeah,
12x.
12x. It should, because you're cross multiplying.
Oh, okay, yeah. So there we go. Now let's see if does changing this to 12x fix anything. So let's say I put the x and everything. Now we have this this new statement is going to be minus x on both sides. So we can subtract 11 from the top. That's going to leave us with 13x over 11 equals 3.
The 13x over 8.
Unless I have done something wrong again, but
Why is 13x?
so you subtract 11x over. Oh, okay, wait. Hold on. So if you have 11x over 11, it should be equal to x, correct? So what if you subtracted this from both sides?
So we have the next one. 13x.
That's what I'm thinking. Like I'm thinking it should be, we convert this form so that both have 11s, and then now we can conveniently subtract this from both sides. So 24x minus 1 minus 3 is equal to 0 because we subtracted x from both sides essentially. Like this is all it's doing. So then this goes into 13x over 11 equals 3. And this answer looks more correct because x is going to be 13 over, no, 11, no, 33 over 13.
You should just multiply the guys.
Oh yeah, you could have done it a much simpler way than I have done it up here. But yeah, your answer is like 33 over 13 for x, and x is defined to be the shadow, so that should be our answer.
And for the previous problem we did, the midpoint thing is actually relevant because of the it's actually relevant because look at the things the similarity kind of we have a GF.
AB with FD and HGF.
Yeah, so
Oh, okay.
it's actually relevant.
Okay, yeah. So you will need this because the thing that you're trying to compare is not going to be with the same, dealing with the same exact triangle. So it deals with a segment that's congruent to the similar triangle.
But you can just have, yeah, you can just have GF congruent to FE, and then it would be like the same thing.
It is the same thing, but you would have to go through the same process to get there, and you still have to show the triangles. Yeah. So you just need it for the very last step, which is like basically substitution. Let's see, we're at 8.5, and that is the last one for 8. So you guys have a 10-minute break. Feel free to, yeah, I don't know where the snack basket is. Oh, wow.
There's a list.
Oh yeah, feel free
Those are
to
like
enjoy.
a couple days old now.
I'm pretty sure Edward always has that basket somewhere around. Oh, it's right down there. Oh, okay. Yeah, feel free to grab. I'm sure a lot of nuts in this one. It's like he saved up for today.
Wait, so Dennis.
Yeah.
Tomorrow, what time is geometry?
Let me check the schedule.
Okay.
I believe it's the same time as today, but let me just make sure.
Oh, okay.
Courses, geometry. Okay, Sunday 1 to 3. Let's double check this. Sunday. This day is wrong, but yeah, 1 to 3.
Okay. Because like I think algebra 2 is 11 to 1 on Sunday.
It's 11 to 1. Yeah. I think I'm not sure if I know I'm definitely subbing for algebra 2 today, so that's going to be like
There's algebra 2.
okay, so that's for the other class of algebra 2.
Oh, okay.
Okay, yeah. So I think I'm subbing for Jimmy for that, but then tomorrow is I'm not sure what the plan is, but I think he might be back tomorrow.
Okay.
So yeah, whatever your current time is, I'll double check with Edward just to make sure, like 100% sure.
Sure.
But yeah, assume that geometry is still the same time for tomorrow, 1 to 3.
Wait, so this packet?
Yeah.
Isn't it what we did with Jay? Lesson 8?
Only the first, first 3, right?
Okay, first 3.
So this is going to cover 3, 4, 5, and then we're going to do 9.
It sounds makes no sense. So why does it wasn't that fun? How does it eat? It's like I would eat really like it doesn't eat. Every time you go to the door, you like leave your mouth like just becomes so think about it.
So you think we'll finish geometry next week?
Yes, me and Edward are trying to wrap it up next week.
What day?
Most likely we'll be taking the whole week. So I will be gone by Friday. So hopefully if we can finish by Thursday, that would be like the most ideal. Next Monday, or you mean like the day after tomorrow? Okay. Okay.
I'm not gonna be gone. Like I thought I was gonna be gone, but it's actually the next week. So if we're finishing this weekend.
Okay. Yeah, like I think we should be able to finish by next week. Because yeah. Yeah, because looking at the schedule, we're just about to finish with chapter 8, so let's say we're on 9, and then that means we just have this, and we're probably going to be combining these 3, so that saves us a day. And the exam, like we're considering making a take-home exam, so it should like save us another day, and that means we should probably be able to finish by Thursday. But it's still kind of up in the air. We're trying to get it figured out. You guys know the Pythagorean theorem, right?
Yeah.
So this chapter should be very, very easy.
What is it using? No. It's kind of like orange.
Okay, yeah, this chapter is actually very, very easy. Oh, introduction and trig. That might be a little bit harder to understand.
Oh, true.
Wait, but Anish, you're doing trig, right?
Yeah. So wait, is this literally just
You're
trig?
stroking its face.
This is easier than what you guys do in trig
Oh, okay.
because you learn more about like
Like, I do like the trig, like the functions and the unit circle and stuff.
yeah, they don't cover unit circle in here, so whatever you're doing trig is probably harder than this. So this should be like super easy for you.
What is that?
He's stroking its
You learn what sine, cosine,
Oh, okay,
tangent
alright.
is. Yeah, the stuff you're doing is you'll be doing stuff with identities and rearranging equations and stuff, and that stuff is definitely harder than stuff here.
Okay. Yeah, we did identities yesterday.
Oh yeah,
So like nobody came for some reason. Like the algebra team, I was the only person there.
you're the only person there.
Yeah, that's
Oh.
really weird.
Was it Jimmy teaching?
No, it was Lucille.
Oh, okay.
Huh.
Yeah, I don't know. They actually made it that lesson in algebra too, because nobody came.
I always thought the trig identities are kind of fun because it's kind of like puzzle solving. It's like, how do you rearrange this so that you get the form you want?
It's just like, here, you just take it again.
Puzzle solving is only fun when you get
Oh yeah, definitely.
it.
Like, that's actually that's kind of like a joke I always use, like in computer science. Like, this stuff is really fun when I understand it. It's not fun when I don't.
No, this is his ear. I think fucking Spotty is here. Why is it you're not this thing? That's on here. This is the ear. Okay, I think this is. So, I mean, when you keep on rolling your feet into here. Why is that like? Maybe. Well, at least Giga looks like makes kind of more sense because you could have a face somewhere. Hey, what is it? That's not the ear. What is this? I don't know. Is this its face? Well, what's that? Was that an eye or was it something else? That's his ear.
It's 2:10, so let's get started. We have 3 theorems involving proportions, so we can use to establish proportionality. Theorem 65, side square theorem. If a line is parallel to one side of a triangle and intersects the other 2 sides, then it divides those sides proportionally. So you have BE is parallel to CD, and you want to prove AB over BC is going to be equal to AC over ED.
Is this 9.1?
No, this is the last chapter of 8,
Okay.
and then we'll move on to 9. So why is it that we can say AB over BC is equal to AE over ED, given these 2 lines are parallel? How do we prove theorem 65? Like, yeah, that's basically what I'm asking.
Because it makes like this congruent angles.
Where are the congruent angles?
A, B, B, A, C, D.
Okay, yeah. So we have the corresponding angles are going to be congruent. We have A is congruent to itself, so we know these 2 are similar. By similar triangles, we know that the ratios must be the same. So that's how we get the side splitter theorem. Theorem 66, if three or more parallel lines are intersected by two transversals, the parallel lines divide the transversals proportionally. So now instead of two lines, we have three lines. And then this is kind of the same thing. We have AC over CE is going to be equal to BD over DF. Same idea. But instead with this one, it says if you want to prove it, you must draw the auxiliary segment AF so that we can see, we can use the side splitter theorem to prove this. Theorem 67, if a ray bisects an angle of a triangle, it divides the opposite side into segments that are proportional to the adjacent sides. So you know BC over CD is going to be equal to AB over AD. Looking at problem number 3, we have RVS is congruent with SVT. We want to find ST. So by theorem 67, you know that VR is going to be VR over VT is going to be equal to RS over ST. And what does theorem 67 say? Theorem 67 is the angle bisector theorem. So if a ray bisects an angle of a triangle, then it divides the opposite side into segments that are proportional to the adjacent sides. So that's how we use this. So this is going to be congruent with this. We can use the equation as given, plug in all numbers, solve for ST. Here, let's try number 7. Tell me what you guys get for X. What did you guys get for X?
9.
Did everybody get 9? Did we get different answers? So everybody here got 9? Okay. Not everybody gave me a response, so let's do it together just to make sure. All right, so was the theorem say which sides are going to be
which ratios are going to be equivalent to which.
X over 6 and 6 over 4. Or 4 over 6 and 6 over x.
So did everybody get the same ratio? You did 6 over 4 and x over 6. Okay, yeah. So it seems like everybody got the same thing. So that is that's correct. It should be 9 then.
Hmm. Oh, let's try 26.
Do we have to simplify it just like in terms of x?
I think you might be able to get a real number answer.
Oh,
Yeah, like comparing the ratio, see if you get like a numerical answer.
um, there's like, I get like a quadratic equation.
Yeah, quadratic.
Now that's like my final answer though.
Let's see what everybody else gets, and then we'll see. Yeah. Thanks. All right, let's work it out together. So what's the first thing we should do when we see this block of perimeter? So yeah, we're gonna use some ratios to try to figure out what x is, try to figure out what y is, so we can add everything up. So what's one ratio we should use? X minus 2 over y4? But when you're using this ratio, aren't you comparing two sides of two different triangles?
Wouldn't the ratio be the same?
Yeah.
The over that is will be the same as the long side.
Isn't that what you kind of want? Because you're trying to solve for x, right? You don't know what x is.
Well, it's x minus 2 over 4 and x minus 7 over x plus 7 over x.
I'll just write down what you have. So you said x minus 2 over 4.
Equals x plus 7 over x.
X plus 7?
Yeah, because like the long side is
Over x plus 7 over what?
x plus 7.
Itself?
The other side is also x plus 7.
Where does that x plus 7 come from?
Because GH is 9 and GF is x minus 2. If you add that, you get x plus 7.
Oh,
And K4 and KJ is x plus 2, that's x plus 7.
oh, I see.
Wait, so then what goes in the denominator?
X plus 7.
Isn't this just equal to 1 though?
Yeah. Because this is x plus 7.
Put a question mark because we don't know for sure yet. But let's say this is true, then x equals times 4 times 4. Add the 2 on both sides, we get x equals 6.
6, yeah.
So the way I was thinking about how this works is that you have this side of the triangle over the larger side is going to be equal to this side of the triangle over the larger side. So the resulting equation would be x minus 2 over x plus 7 is going to be equal to 4 over x plus 7. But in this case, I guess it's the same. It turned out to be the same. Okay, well, I mean, since we got the same answer for x, well, let's find y. So what is y going to be now that we have x is equal to 6?
You can do like 5 over y is equal to 9 over 10.
Where'd you get the 9 from?
Well, I mean, like, You can just do any ratio on this on the.
Oh yeah, I'm just asking like where in
Oh,
particular.
it's GH.
Uh,
GH and KJ.
okay, so you're saying this one with this one?
Yeah.
So how come so you have this ratio involving the small triangle and the big triangle, right? But
Yeah. Never mind. That doesn't.
well, you're on the right track. Like you just have to pick a pair of angles that are one from the big one, one's from a small one, one's from a big one. Small over big, small over big. Just fit that pattern.
Okay, so like x minus 2 over 9.
So what's going to be the total length of that side? Is it going to be?
Oh, that's x plus 7.
Yeah, so we're going to have x plus 7. So we know what x is because x is equal to 6. So 5 over y is going to be equal to 4 over 13. Now let's multiply on both sides by 13. So we get 5 times 13 is going to be equal to 65 equals 4y. Y equals 65 over 4. You have x and y, you just plug everything back in. And there you go. That's your perimeter.
Yeah, so that is it for chapter 8. We move on to chapter 9, which is
Oh, yes.
a review of radicals and quadratic equations. So I'm pretty sure everybody here has done quadratic equations and radicals before, except maybe Warren. But it's okay, Warren. You can catch on pretty fast, I feel. So do you guys all know how to simplify things in radicals? Find the squares and take out the squares. So find the squares, take out the squares, add up the similar terms. Okay, well, when we tell you to simplify a fraction inside a radical, just take the radicals for both of them and you multiply by the radical on the bottom. So this is equal to 1, multiplied by 3, and then your radical then becomes square root 15 over 3. That's what you want. All right. Okay. So I'm pretty sure all you know how to do this. Okay, so Warren, I'm not sure how much of this you'll get in one day, but so whenever you want to solve something that involves a x squared term, sometimes it's really nice and it comes out to a nice even number like 16, and then you take the square root of both sides, so that gives you positive or negative 4, because if you multiply negative 4 times negative 4, you can get the same answer that you want. So that's the first one, if it's very nice. The second one is way that we do called factoring. So let's move all of the like terms to one side. So we have the x squared on here, and then we have, or we don't move it to all to one side, but we want a 0 on one of the sides. So we subtract 25 on both sides, we get x squared minus 16 equals 0. Now the way factoring works is that we have a combination of numbers such that this number times this number plus this number times this number plus this number times this number plus this number times this number. This is going to be equal to the same thing as this. So that's what we call factoring. And then once we have this, we know that because this number is 0, as long as this term is equal to 0, or as long as this term equals 0, then either case is fine, and that gets us what we want to get. So we say this is equal to 0, we say this is equal to 0. So we have both of these here. That gives us the two possibilities of x is equal to 4 or x is equal to negative 4. And sometimes we have things that look a little bit more complicated, like this, and we have 3 times radical 5 squared. So you guys know how multiply radicals is just you multiply this times this, and then this times this will equal 5. So 9 times 5 plus 9 times 2 equals x squared. Yeah, square root of 63. You want to take you want to find x by itself though, so then you just take out the square, and there's your answer. Okay. What is square root 98 going to be equal to?
Uh, 7√2.
Yeah, 7 root 2. So it's going to be 7 root 2 because you have the fastest way I can think of doing it is what's going to be, let's say you divide by, yeah, like what's going to be a factor that, the largest factor that can also be a square. So the first thing that comes to my mind is going to be a 49 because 7 times 7 is equal to 49. And if we have 49 times 2, then that's equal to 98. So that's a, I guess the fastest way of thinking about it is just like, what's the largest square that I can use, and then use that. Or what you can also do is keep on dividing by 2's until you get a number that's not either it's a square or it's not divisible anymore. So let's say I have no idea what 72 is going to come out to be. So it helps to be able to do these like either really fast or in your head. But let's say I have square root of 72. I have no idea what it's going to be, but I'll just say, what if I divide this by 2? Then I get 36 over 2. Is 36 going to be a square? Yeah. So let's remove the 36, and then we get 6 root 2. And that's our answer for 72. And if we have something like, let's say, I want to use a harder one, but it doesn't look like they have any here. But okay, let me just write some larger number in which I don't even know the answer to looking straight off the top of my head. Okay, so let's say I have a number like 372. Like I don't know what could possibly come out to just by looking at it. So let's say I divide by 2. What's going to be this divided by 2? Well, you get that's going to be 17 times 8, so that's going to be 12, or 86 times 2. Yeah, okay, so if I did my math right, it should be 186 times 2. Now let's divide by 2 again, so that we get a number that's small. So dividing that by 2, we get 93 times 2 times 2. Now, so it doesn't look like 93 is divisible by 2 anymore. So what number can we divide by to break it down even more? Yeah, so let's divide by 3. So dividing that by 3, we have 31 times 3 times 2 times 2. Okay. Now, is 31 divisible by anything? Yeah, so 31 is prime. So that's the smallest we can leave it be. And now we know that 2 times 2 is going to be equal to 4. 4 is a square. So let's drag this out to the top. So now we know it's going to be a 2 radical 31 times 3. And, well, that's just going to be equal to 93. So just by dividing by small numbers like 2's and 3's, we can usually get to where we want to get. Okay. Solve for x, d. X squared minus 18 minus 3x equals 0. Where I would say it's okay if you don't understand how to do this because like learning how to do quadratics and factoring does take a little bit more time. So that's something you're probably going to learn in your school year. But did anybody else get any answers for D? Yeah, so it should be 3 and 6 based on wait, hold, yeah, one of them is going to be negative 6 and negative 3. Okay, so that was that. And that was supposed to be a review of radicals, quadratic equations. Let's go on 9.2, introduction to circles. You guys have already done some problems with circles before, and so find the circumference and area of a circle. You guys already know the formula. So circumference is going to be the distance around the circle. Area is going to be the total space inside of the circle. So circumference equals C equals 2 pi r, area equals pi r squared. So very, very important to know in geometry. So we have what is called an arc. An arc is part of the circumference. Arc is made up of 2 points on a circle, and all the points on the circle need to connect those 2 points by a single path. The blue portion of the figure on the right is called CD. So this is going to be arc CD. So we know a complete circle is 360 degrees. And the length of an arc is a fraction of the circle's circumference. So we can express it in similar terms. So let's say we have a 0, 6 and 6, 0 on this graph right here. And we know that the angle measure is going to be 90 degrees because this is exactly 1/4 of 360. So we know that the length of this arc is going to be 90 over 360 times the circumference of the circle. So that gives us 1/4 pi times the diameter of this guy. Diameter is going to be, well, 6, and you have 6. So diameter is 12, and you divide by 1/4, you get 3 pi. So that's 3 pi is going to be the length of this segment over here. Now you can do the same thing with area. So let's say you want to find the area of this quarter circle. What you can do is you can find the total area, which is found by using pi r squared, then just divide by 4, because you know this is going to be exactly 1/4 of the entire circle. Okay, like chord or chord is a line segment joining 2 points on a circle. An inscribed angle. So this is kind of important. Like this will show up in a lot of problems. Inscribed angle is an angle whose vertex is on a circle and whose sides are determined by 2 chords of the circle. AB, AC are chords because they are line segments joining these 2 points on the circle. BAC is an inscribed angle. So we say angle BAC intercepts BC. All this stuff is fairly simple. Yes, we're in distance formula. You have x plus x divided by 2. You have x plus x divided by 2. Or that's the midpoint formula. Let's see. Okay. So in this diagram here, we have this arc length is equal to 90. We want to find angle F. I believe this might have been mentioned up here somewhere. Okay, it might not have been mentioned. Oh, okay, okay. So that is something that we're going to learn in chapter 10. So, yeah, this question is not a very good question. But how to solve this would be, for every inscribed angle you have, you take the half the angle of the arc length. So you have 9 degrees here. To find the inscribed angle, all you do is divide by 2. But you don't need to know this quite yet because that's in the next lesson. But since they use it so much, like I don't even know why they didn't put in this one. But that's okay. We're going to get to there very soon. Let's see. Okay, 9.3, altitude on hypotenuse theorems. So when we have altitude CD drawn to the hypotenuse of ABC, 3 similar triangles are formed. We have a triangle ABC is going to be similar to ACD. It's going to be similar to CBD. ABC is going to be similar to this by AA. So that's because we have the this one, and we have the 2 right angles. And we notice that AB over AC is going to be equal to CD over AC over AD. Also, it can be written as AC squared, cross multiply, equals AB times AD.
Question?
Yeah.
So I'm still kind of confused about like the properties of altitudes. Like, does it just like create like a line with a 90-degree angle? Is that?
Yeah. So what an altitude is a line drawn from one vertex to the other side. You create a 90-degree angle. So that's all the altitude is saying.
Why is ABC similar
To which one?
to this?
Okay.
Oh, never mind. I see.
Okay. All right. So we use AA quite a bit in proving that all three of these are similar. Yeah, so just look for like which angles are shared, where the 90-degree angles are, and that should be able to tell you things about the triangle. Theorem 68, there is quite a bit about Theorem 68, but that is the only theorem, so yeah, I would copy down like most of what's important in these three steps. So if you have an altitude drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the given right triangle as we just saw. So this one is going to be similar to this one, is going to be similar to the big eye. You also know that the altitude to the hypotenuse is the mean proportional between the segments of the hypotenuse. So xh over hy, which is going to be the corresponding corresponding sides to one another. So B is probably going to show up in some of the practice problems or homework. So whenever you see I have a right triangle, I have an altitude, you can just think, oh, a squared is going to be equal to x times y if you know these two values, if you know the altitude value. Yeah, for I feel like it would be useful to write down most of what's here, but the bare bones minimum I expect you guys to have is draw this diagram, write down the similarity, write down the equations, write down the equations.
Wait, so are these chapters just like taking algebra and like applying it to geometry?
Yes, you can think about it like that way.
So we don't use these with like proofs, like besides the theorem.
In this one, yes, you can use this one in a proof.
Okay.
So let's say you have something like this triangle over here, and you know this is altitude because this is a right triangle, and then this one's a 90-degree angle. So you know what we can do is we can use one of the equations from up above here. So we don't know what the length of altitude is, and we want to find out what it is. Well, we know in this diagram, this one, so h is going to be your altitude. So you know h is going to be h squared equals x times y. Well, in this one, you know, let's call this h. So you know h squared is going to be x times y. So you have h squared equals square root 27, and then that turns out to be 3 square root 3. We take out the negative sign because CD cannot be negative, because CD is a line segment. Now we over here we have a different case. Well, if we don't know the hypotenuse, we don't know the altitude, but what we're trying to find is going to be this side. So now let's look back up to our diagram. What's the side that we want to find? Well, it looks like we want to find A. So what's the formula involving A? Going here and say, well, A squared equals y times C. So we have a squared y times, and c is the whole length. A is going to be this side, y is over here, c is the whole length. That means that a squared equals y times c. So that means x squared equals 3 times 12, which is 36. X has to be equal to 6. Same thing with this, just match up the equation that you want to use. And this is how, or this is where we would be using the proof. This is where, let's say we want to prove PO times PM is equal to PR times PJ. So what we can do is we can use one of those theorems up there to get the form in this kind of format. So we have this squared equals this times this, then just rearrange to get what you want to get. So let's do let's do this lake problem. Everybody got an answer? We want to find out how far the B is to C. Once you guys are finished with this, you guys are done for today.
Can you assume that the triangles are similar?
So why are they forced to be similar? Actually, in this case, you would have to assume that angle DBA is a right triangle. But yes, assume they are similar. Imagine right triangle and you have the altitude. Just pick pick your most favorite equation and then use it with this.
Gotcha.
Okay, well, why?
Because B is they're similar, and AB and TB is the corresponding units. And DB and CB are corresponding. And the ratio is 2 to 1, 1 to 2.
Okay, so that might be one way to do it. But let's try the shortcut way, which is using the equations. What's going to be the relevant equation that we want to use? So the ones that you should have copied down, the ones up there that I just used. You have you have 1, 2, 3. Pick one and then apply it to this problem. Okay, so what is going to be, what's the equation that you use? X over h equals what? H over y. And then okay, so what so we know our h is going to be 6, right?
Our y is
Okay, so we know h is 6, y is 3. So x is supposed to be 12. So there we go. That's our answer. And homework for chapter 8 is on the very last page. And that's it for today. Hey Edward.
Yeah.
Nish wants to know if algebra 2 is at
11 to 1. Because like I remember the last algebra 2 lesson, I was like the only person there. Yeah.